everyone, my name's Anne and I'm making this video to share with you my understanding about function. So here we go. So let's take this basic example. Fx equal x. So if we take 1 as the input of this function, we will have the output is 1. So we have fx equal 1. It's very simple. Just replace x with the value that we are evaluating and we will have our result. One function and with one value, we can only have one output. Let's take another example for this. Fx equal 2x plus 1. If we use the table of value, we will see clearly why one value can always have one output. So this is the input and this is the output fx. Let's take 0, 1, 2, and 3 as our example input. If we have 0 as our input, we will have and replace x with 0. So this part is 0. So our output is 1. And let's do that for other input as well. 1 here, so this is 2, and this equal 3. 2 here, this is 4, and here we have 5. So in 5 here, so we have 6 plus 1 equals 7. So you can see that with one input, we can only have one output, and that's a function. Furthermore, the value of x as the input doesn't always have to be a number. It can be a variable. For example, let's take fx equal x plus 10 over x squared plus 4. Now let's evaluate f to x squared plus 3. So what is our result? It's really simple. Just replace x with 2x squared plus 3. This was our x plus 10 and 2x plus 3 is 4. And here's our result. Now let's examine function through its graph. So here I will explain how to graph a function. Let's use the previous example. So here we have x as 0 and fx 1. This is our first point. This is 1, 3. This is our second point. This is 2. So here we have the graph of fx. Usually we only need 2 points to graph this function. And from a graph of a function, we can see clearly that one value of x can only have one value of fx. Here is 1, and it can only have 3 as its output. Usually we use the vertical line test to see that if a graph is a graph of a function or not. This is an example. So I will use this ruler as the vertical line. Just imagine that it's a line, and for example, if we have a graph like this, and as we move our line through this graph, you can see that it's with each x is only have one value of y, fx here. So this is a graph of a function. And it doesn't have to be a straight line to be a function. And for this example, if we use the vertical line test, we can see that this function with 1x, it has 2 value of y here. So this is not a function. This is how we use the vertical line test. And from a graph or a function, we can evaluate the value of that function. For example, like this function. If we take this point and do like this, we can evaluate that this point has coordinates of 2 and 2. So this is how we evaluate a function from its graph. And next, I will explain about domain and range of a function. So let's use this example again. So previously, we call this part is the input, and this part is the output of a function. And actually, the set of x that we use to insert here is called the domain. And this part is the domain of a function. And this part, we previously called it the output of a function, but in mathematics we call this part as the range of a function. So each function has a set of its own domain and range. And when we do our exercise, we usually face a question tell us to find the domain of a function. So how are we gonna do it? It is basically finding the set of x to make that function, the input of that function meaningful. If we view function as a machine, like this. So if the input here is indivisible, and the machine cannot understand it, so we cannot have our output. So finding the domain is finding a set of x that make this input understandable. So let's use this example. So I will find the domain for this function. For this function, we have two conditions. The first one is this part. This part is under a square root, so for x plus 5 must be greater or even with 0. And this part, this must be x minus 6 but not equal to 0. So we have so here is the condition for this function. If we write it as a set, we will have the domain for this function is and here is our result.